Hello, this is Dan Alford with ARC Specialties. I'm in here with one of our newest employees, Evelyn. Say hi to the camera.
Hello.
Evelyn has been hired to do two different things. Tell us what you do.
The first thing that I do is mechanical drafting, so that's just drawing up simple parts and dimensioning things so that the guys in the shop are able to actually produce what we design. And the other side of my job is robotic simulations. And so right here I have RoboGuide pulled up, and I have 9 robots right here set up to simulate a job that is potentially in the works.
So one of the biggest things you have to do in robotics is a reach study. And one of my examples is there is an electric car company that will remain nameless that we worked with, and we had our robot ready to rock and roll, and they did their own robot to load our robot, and when they turned on their robot, it did this.
Yeah.
It couldn't reach the part. So we shut down. They gave the robot a arm graft or something, and we had the same thing happen recently at a nuclear company. Oh. They positioned the tool changer outside of the reach of the robot. So at a minimum, that's what I like for you to do is get a reach study. But this goes way beyond that.
Oh yeah. If I pull up the splice section of that 9 robot series, I'm able to run my entire program and watch as the robots move.
Outstanding. So why do you have so many robots?
In that particular job, having more robots means that we're actually able to reach all points on the part because it is 60 feet long, but it also reduces cycle time and
2 robots weld twice as fast as 1 robot, right?
Yes.
And a lot of times we'll put, the point is, a lot of times we'll put a travel unit there. So if it's just an envelope problem, a travel unit will solve the problem. But in this case, you eliminated a travel unit and sped up the process. Yep. Plus our friends at FANUC are going to love you because that's a lot of robots.
Oh yeah, oh yeah. The price difference between a standard robot, no travel unit, plus the travel unit and all of the different software packages that need to come with it, it's about $20,000. And if you want to compare the prices between 9 regular robots versus the 5 that we had previously gone through, because we did do that study as well, the price comes out the same.
Interesting.
So it's faster, it's the same cost to just have more robots.
Well, that's fascinating. I'll try to remember that one when we're out and about. So this one is RoboGuide, right? That's proprietary software from our friends at FANUC. Well, what about our friends at KUKA and ABB and such?
All of them have their own simulation softwares. We just don't have the license for them yet.
So we need to work on that.
Yes.
Okay, so this is going to hopefully help us sell a job, and then after we sell it, then that's the other half of your job, right? You're going to work with the engineer and to design all the pieces.
The way that it's kind of working out now is they design them, they have them rendered and all that, and then I go in and I make all of the IDWs or the paper drawings for them, and those are the ones that get printed.
But if I understand this correctly, you're 1 year away from having your engineering degree.
Yes.
And so someday you'll have a design draftsperson working for you.
I look forward to that day.
All right.
I need to go back.
You need to go back and finish this up.
Yeah.
Well, you're doing great things. This is really helping us out. I think it's making our proposals much more credible, and I think it's saving us a ton of trouble. Oh, yeah. If you correct a problem while it's on the screen, that's a whole lot cheaper than correcting it out in the shop.
Oh, yeah. With RoboGuide specifically, I'm able to turn on collision detection. I can test through all of the different software options that FANUC offers for each of their robots. I have access to every robot that they have, and I'm able to figure out exactly the way that these robots would need to move in a specific environment. I can program them to avoid obstacles, to turn on their welding torches, different tools, change their tool ends. It's incredibly important for us to be able to figure out where the robot can actually reach. Like these tool changers, that's something that we got from Albacore Benzel, and these torch cleaners. Bill wasn't sure if the robot was going to be able to reach the torch cleaner when he initially drew up this concept. But through reach studies, we were able to determine that that is the perfect spot for it.
So he got lucky. Either that or he's good, one of the two. And I believe you're going to be changing torch necks on this because you're going to have a special torch to weld the bottom side. What's that going to do is prevent us from having to flip the entire part, which would have been another $100,000.
Oh yeah. And it also enables us to limit the amount of joint movements on the end of the robot. So instead of having crazy, insane angles on joint 5, where we would lead to cable breaking, and that's not good when
No.
we're trying to weld and maintain robots for a long period of time. So with this U-shaped torch, we're actually able to weld from above, but it's underneath.
It's an upside down backwards torch. Interesting. So does this help you with singularities?
In this environment, yes, but singularities seem to find me. So
Interesting.
singularities they're a pain in the butt to work with.
No, I'm just glad you're worried about them because
Yeah.
I worry. It keeps me up late at night.
Yeah. If I encounter a singularity, RoboGuide shows me it's a fault and that there's something wrong. It will also indicate which group number, which is the robot, and then the specific axis that is encountering a singularity.
Amazing. This is so much better than the old way, trust me. Because I've been doing this for 40 years now. So when has the customer seen this yet?
I believe they've seen a couple of the studies that we've done,
But not this version.
but not this version.
Oh, they're going to love it.
I hope so.
When will you be finished?
It's pretty much ready now.
Very cool.
I think that there's just some final touches that I need to make, specifically to determine the actual cycle time with proper weld speeds.
And that's something this will give us very accurately.
Oh, yeah.
Because you know the deposition rate and the weld sizes.
Yep, and I can also program the wire feed speed and the amperage and the current, everything that goes into making welding happen, I'm able to program within. And when I have it set up to actually run with welds, real welds, it'll also give me information about how much time it's actually on, when is it just moving.
So you've automated the process of automating.
Kinda.
Excellent. ARC Specialties thrives on problems.
Send us yours.